Hello everyone, good morning. IM3 students. Today we're going to work on 7.1 day 2, and that is on finding rational solutions of polynomial equations. And we will be solving for the zeros of the polynomial functions using the rational zeros theorem. So let's go ahead and take a look at the steps of finding the zeros using rational zeros theorem. The requirement for using this theorem is that we only use if you cannot using any of the factoring or grouping method. Remember, this is like the last resort of finding the rational zero. If you can factor it using GCF or using factor by grouping or any other factoring method, you should do that first. And you only use this method if you cannot factor it or using any other way. So that's want to make sure that we clarify that as a last resort we use this method because it's really a long process, and that's why we want to refrain from using it unless it's necessary, right? And then also, obviously, if you have more than 4 terms, you cannot factor it anyhow, so you have to use this method. If you have more than 4 terms, automatically it prompts for this method. And I usually call this the PQ method. So these are the steps to finding the zeros using the rational zero theorem. And I will walk you through it using various examples after I clarify. So the factor of the constant term is, we call it P. So the number all the way at the end is P. In this case, this is P. And then the factor, the leading coefficient is Q, which means the number right in front of the very highest degree. We call that Q. So we basically use the factors of P and Q to find the list of possible zeros first. So the possible zeros are obtained by using P over Q. And then this next step is using the list of possible zeros. We will be testing and find one that works. So then we will use that to finish. And then we'll continue with the synthetic division until everything is factored and we can find all of the linear zeros. Okay, so those are basically the steps. And we're going to just walk you through all of those steps right now using an actual example. So here we have an example of an actual polynomial function that is 4 terms. So you might be thinking to yourself, can I factor this using the GCF, factoring anything out, or grouping? So you'll realize that it does not really go through for the factoring process. So we need to use the rational zeros theorem, which is involving the PQ method. So we know that P is actually 35 and Q is actually 1 because the coefficient in front of the x cubed term is 1. So using the P over Q method to find the list of possible zeros, we're going to list the possible factors, the possible zeros, by listing the factors of P, and that's 1 and 35. And I like to list them in in pairs. So 1 times 35 is 35, and also 5 times 7 is 35 as well. So those are all of the factors of P. And then if we want to find the factors of Q, that's only 1. So it's just plus or minus 1. So if you take everything on top, P, divided by everything on the bottom, you're always going to just get what is on top, right? So always, if you're only dividing by 1, you're always going to get everything that is on top. So the possible zero is going to be from this list. So we have actually 8 possible zeros. So 8 possible zeros. It does not mean that all of them are going to be zeros, but they are possible. So we have 8 of them, and we just call it PZ for short for possible zeros. And let's actually begin the process of testing these zeros. And we're going to write down the coefficients. So that's 1, negative 11, 23, and 35. We're going to use synthetic division. Everyone should know how to do synthetic division by now. So we're going to actually test our first one. We're going to test negative 1 because that is one of the factors in here. So bring down the first steps, bring down the first term. That's 1, and then we're going to multiply. 1 times negative 1 is negative 1. Combining these two, we're going to have negative 12. Multiplying by the divisor again, we're going to have 12. And then combining these two, we will have 35. And then finally, multiplying by negative 1, we will have negative 35. And that gives us a 0, which means that we have a factor. So we do have x minus 1, x plus 1. The factor form is x plus 1, but the zero form is x equals negative 1. So we have 1, 0 so far. And we're going to rewrite the rest we're going to reduce write the rest of the polynomial by reducing the degree. So we started with an x cubed right here, and we're going to reduce it by 1. So we're going to rewrite it as x squared minus 12x plus 35. And we will proceed to solve the 0 for the remaining and by factoring. So the signs are the same. Both of them are going to be negative. So negative and negative. Two numbers that multiply to get 35 and add up to get 12 are 5 and 7. And so we have x equals 5 and 7. And with the one that we have, the negative 1, so the complete list of zeros are negative 1, 5, and 7. And so that would be the complete list of zeros that we found by using the rational zero theorem or the PQ method. And that's the end of that problem. Now let's go ahead and take a look at the next problem, which is also a polynomial function. And this time, if you notice, the problem actually has a common factor in there. I don't know if you realize, but remember, I said that try using GCF, factor anything other method other than PQ method. So right away, we can see that I can factor out an x. So I have x squared minus 2x minus 8. From here, I can actually factor the rest into x minus 4 and x plus 2 and bring down the original x. So this is the complete factorization of this polynomial function. And then the list of zeros are 0, 4, and negative 2. So that's the complete list. And we didn't even have to involve the rational zero or PQ method. So we did it all by factoring. So that's just an example to show you that don't use that method unless it's necessary. Let's go ahead and have you do the try it problem. So you can go ahead and try this problem, pause the video, and try it before you look at the answers. Okay, hopefully you've had a chance to try the problem. We're going to try to factor, but if you realize that there's actually no way to factor using the grouping method, it's not going to work out. So we're actually going to have to use the PQ method, the rational zero theorem. And so finding the factor out the possible zeros by finding the factors of 20. So that will be 1 and 20, 2 and 10, and then we have 4 and 5. And I think that is everything. So there's total of 6 times 2, which is 12 factors of P. And then Q, the coefficient of the highest degree is 1 as well. So we're going to be just dividing by plus or minus 1, which just give us the top list as the complete list of possible zeros. So there is our PZ. Possible zero is this list right here. So now we're going to get ready to test the possible zeros by using synthetic division. So we need to bring down the coefficients. That will be 1, negative 11, 8, and 20. And then we're going to test out the first zero we're going to test is negative 1. We're going to bring down the 1 and multiply. That will be negative 1. Combining the 2, we have negative 12. Times negative 1 will give us 12. 12 plus 8 is 20. Times negative 1 gives us negative 20. And wow, we have a 0. So because we found the 0, we have x equals negative 1 is one of the answers. And we're going to rewrite again by reducing. So it will be reducing by the degree of 1. That will be x squared minus 12x plus 20. And we're going to try to attempt to factor this. So I can see that I can factor it into x. Signs are the same. Two numbers that multiply to get 20 and add up to 12 are 2 and 10. And so I have x equals negative 2 from this list right here. And actually not negative 2, positive 2, 10. And then the original one that we found, which is negative 1. So here is the list of complete answers. And if you wanted to write the answer in the factored form, the complete factorization would be P of x is equal to x plus 1, x minus 2, and x plus 10. And should be plus. Actually, it should be minus 2 and x minus 10. So there's the complete list of factors, and those are the zeros that we found using the rational zero theorem. Okay, and that's the end of that problem. Go ahead and try this problem before you move on. So go ahead and use whatever method you feel is appropriate to solve this. Okay, hopefully you've had a chance to try it. The first thing that I'm going to do is actually, I realize that there's an x in all of them, so I'm going to factor out an x first. That will make the problem 1 degree less, right? So I have that. And I can take a look at this list of 4 terms here and try to use GCF or factor by grouping, but I don't think it's going to work. So I have no choice but to use the PQ method again. So P over Q. The factors of 24 is going to be kind of long now, so it's 1 and 24. And then we got 2 and 12, and then 3 and 8, and we also have 4 and 6. All right, so those are all of the factors of P, and then Q, again, is plus or minus 1. So we are lucky we don't have to divide anything else other than 1, and that is the list of possible zeros right here on this list, and it is the total of 3, 4, 5, 6, 7, 8. 8 times 2, 16 possible zeros here. And we're going to test it. And we're going to test by bringing the coefficients down so we can use the synthetic division. So those are the coefficients. And we're going to try, this should be a negative 24. So we're going to try the first method again. First number, we're going to test negative 1. Bring down the 1. And we're going to multiply. We should combine that to be negative 2. Negative 2 times negative 1 is 2. Combining it will give us negative 24 times negative 1 will give us positive 24. And yay, we have a 0. So we're going to try to reduce this to x squared minus 2x minus 24. And finally, factoring it. And we're going to have x and x. The signs are different. And therefore, two numbers that multiply to get 24, and the difference is 2, should be 4 and 6. We want negative 2, so 6 will be negative, 4 will be positive. And so the zeros from here are negative 4 and 6. And don't forget to include the original one that we have, which is negative 1. If I wanted to write the polynomial in factored form, that will be x plus 1, x plus 4, and x minus 6. But the zeros are here, and should use a bracket to contain it. And there it is, the end of the problem with 3 zeros all found using the PQ method or the rational zero theorem. Okay, I'm going to move on to example 2, finding the rational zeros. Write the polynomial in factored form, finding all the zeros. It's basically the same exact thing that we did earlier, and I think the only difference is that we will have a number in front of the leading coefficient is actually not 1 anymore. So let's go ahead and use the PQ method again. So it doesn't look like I can factor using GCF or grouping. So I'm going to do P and Q. And this time, the factors of P are plus or minus 1 and 12, the same way that we did earlier, 2 and 6, and then 3 and 4. So those are all of the factors. Over the Q factors are plus or minus 1 and plus or minus 2 because Q is equal to 2. So those are the actual factors. But we need the possible zero. And the possible zero list is generated by taking everything on top, dividing by 1. So it's everything that is highlighted so far. And then next, we're going to need to divide everything by 2 and add up anything new. So first, we have 1 divided by 2. That's 1/2. So that's going to be new. So I'm going to add that to the list. And then next we have 2 divided by 2. That's 1. It's already on the list, so I'm not going to add it. And then we have 3 divided by 2. That's 3 over 2. So I'm going to add that to the list because that is new. Then next we have 4 over 2, which is 2, and it's already on the list. It's right there. So we don't need to include it. And then 6 over 2 is 3. 3 is already on the list again, so we're not going to add that either. And then finally, 12 over 2, that is 6. It's already on the list, so we don't have anything else to add. So the complete list is right here for the possible zeros, everything that is highlighted. And so we have the complete list on top. Then those are all of the possible zeros, and we're going to test one of them. And let's go ahead and bring down the coefficients first. And let's go ahead and test 3. So we're going to test 3. 2 times 3 is 6. 6 plus 1 is 7. 7 times 3 is 21. Combining, we have negative 4. And then multiply by 3, we have negative 12. And that gives us a 0 again. So we're going to reduce the degree. So it's 2x plus 7, 2x squared plus 7x minus 4. That's what we get. And we're going to try to factor using the crisscross spider method. So it is 2x and x. And we need two numbers that multiply to get 4 and different signs. So let's try negative 1 and 4 and cross multiplying. We should have 8x minus x. That gives us 7x, which is the middle term that we want. So we know that the correct complete factorization for this one will be 2x minus 1 times x plus 4. Set that equal to 0. The zeros coming out of here are 1/2 and negative 4. And don't forget, we're going to add the original one that we found, which is 3, right? So we're going to add 3 to the list. So this is the complete list of zeros. But if you, we need to fully answer the question. So the polynomial that is completely factored is x minus 3 times 2x minus 1 and x plus 4. That is a completely factored list. And this is the 0 list. So let's see if we answer the question. So we found all the zeros, we wrote it in factored form, and that's basically all we did. That's the end of the problem. And it is time for you to try this problem, the next one, before you actually look at the answer. So go ahead and pause the video and try. Okay, so now we are going to try this again. We're going to use PQ method. It doesn't look like we can factor out using the grouping method. So P over Q. And so the factors of 10 are plus or minus 1 and 10, 2 and 5, and that's it. On the bottom, we have Q, so that's going to be factors of 3, which is 1 and 3. So the first thing we do is we take everything on top, dividing by 1, and that should give us 1, everything that is on top. Then next, we're going to need to divide it by 3, and so dividing by 3, we have 1 over 3. So that will be a new factor. So we're going to add that 1/3. And then 2 over 3. And that will be new also. So 2/3. And then we have 5 over 3. So that will be also new, 5 over 3. Finally, 10 over 3. That's also new. So that's 10/3. So the complete list of zeros is including the fraction. So that's everything that is highlighted will be the possible zeros. This whole list right here with the highlights. So that's everything, and we're going to actually test it now to see which one is a good factor. So we're going to write down the coefficients 3, 10, negative 27, and negative 10. The first number we're going to try is 2, and let's bring down the first term. 3 times 2 is 6. 6 plus 10 is 16. 16 times 2 is 32. And combining it will be negative 5 times 2 will be, oh, sorry, it will be positive 5. And then multiplying that will be 10, and that gives us a 0. And we're going to reduce the answer by 1 degree. So it's 3x squared plus 16x plus 5. We're going to set that equal to 0 to finish solving it. Again, we're going to try this factor using crisscross spider method. And we need two factors. 5 is 1 and 5. That's the only way. So let's try 1 and 5. Cross multiplying, I got 15x plus x. That gives me the middle term of 16x, and that is what I want. So let's finish factoring this polynomial using complete factorization. So the 0 of 2 gives me x minus 2. And then we have 3x plus 1 and x plus 5. That is the complete list of factors. And the complete list of zeros are x equals 2, negative 1/3, and negative 5. So that is the complete list of factors. And that is the end of the problem. And that is also the end of day 2. Go ahead and get started with your assignment for today. And have a nice day, everyone. Bye.